I am Shubhankar Roy. I am working as assistant professor in the Department of Physics of Vidyasagar Metropolitan College, Kolkata. Here I will make a short video for the purpose of FDP induction program. Here I will make a video on the system of variable mass. Here I have chosen this topic because nowadays we know that Indian scientists are contributing so much about satellites, rockets, and also we in Diwali and in any occasion we use rocket bombs. So why not we try to understand the basics of this rocket motions. So let's start.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
We know that Newton's law of motion can explain the dynamics of any kind of system of particles. However, for the system of variable mass, we need some modification. So let us take system of variable mass consists of total mass capital M, and here we can see that at time t plus delta t, after combustion of delta m amount of mass, rocket achieves delta v amount of additional velocity. And if we write the momentum terms for the previous part and the final part, so this can be written in this way. Now if we write the definition of force and put the values of final momentum value and initial momentum value, so we will get this equation. So let us write those terms for PF and PI, and after some simplification, I mean the cancellation as well as the amount of delta m delta v being very negligible, so you will neglect this term, and finally we will get this m dv dt plus u minus v dm dt. So okay, so now if we write this dm dt, d small m dt equals to minus d capital M dt, it comes from conservation of mass. Now we replace the term in the equation we got previously, and we will get this equation. So after some simplification we can get this equation. Now for better understanding, we can use this u minus v term as v relative, because this signifies the velocity of that delta small m mass with respect to the capital M mass, and we write in this way, and we get this term, this term, this is called thrust on the system. This gives the thrust on the system actually. So because of this we get the motion of the rocket increasing time to time. Okay, so now if I come to this external term, so this means some external forces applied on the system. Now if we consider this F external equal to 0, or in other way you can say that the absence of all external forces including the gravitational force and also any kind of air drag. So now we can rewrite the equations putting that f external equals to 0. We will get this equation, and if we integrate this differential equation, and we will get this representation of with the integration with m0 and v0 is the initial values. Now we'll finally we'll get the values for our integration. This here v relative is constant, because usually this remains constant for this kind of system. So we got this relation for our this simple problem without any gravitational or air drag, but we can include those terms. So if we include those terms, then we will get a new solution. Those are more realistic, but since the time is limited, so I have to be restricted up to this. So thank you for watching.